Hello, everyone. Today we're going to talk about Server Side Request Forgery attack on the vulnerable web application, PinewoodStore, that was created a few weeks back. I've introduced the Server Side Request Forgery vulnerability in one of the pages, and this video is about demonstrating how the vulnerability is exploited and also looking at the vulnerable code at the back end to see what a typical vulnerable server-side request forgery code looks like. And also, at the end of it, we'll talk about secure implementation using allow list for trusted hosts, which is one way of remediating this vulnerability. Now, with that being said, let's just define kind of like the basic concept, right? Let's start off with that. Server-side request forgery is a security vulnerability that allows an attacker to make an authorized request from a server. This could lead to data exfiltration, internal network access, even remote code execution, depending on the case. And this vulnerability has been exploited in the past on some of the bigger companies to access AWS, GCP, cloud credentials. So it is still prevalent in this day and age. And it also sometimes, depending on your configuration, it might allow you to bypass a firewall. Now, with that being said, let's go over the demo and let's get started on some of the things we're going to be looking at. And I'll also be sharing the full details on SSRF demo that we're going to do in a minute on my blog site, techtalkpine.com. Now let's go ahead and pull up the VM. Now I already packaged the application as a jar file and deployed it to a Ubuntu system. What I did, let me go ahead and log in so we can take a look. Now as you can see, let me minimize this first. The application is running. This is basically the console log. The other thing I want to show you is what we're going to do, what we can demonstrate is there is this admin dashboard. It can only be accessed from a local host. As you can see here, is actually localhost, and you will not be able to access it even from an IP address in the same system. It will give you 403. Now, let me go ahead and pull up the site on what we're going to do is I'm going to demonstrate the vulnerability. First thing, we're going to see what the vulnerability is. The second thing is how to exploit it, obviously. We're going to exploit it and find a way to actually look up the admin dashboard. The admin dashboard generally, the way I designed it, it basically has a source code, right? This is something you don't want to reveal to your to outside attackers. And also just some random generated information, server online and activities and something, kind of like to emulate a typical dashboard, admin dashboard. Now, with that being said, let's go ahead and pull up the site. And just to confirm, just to show you, it is actually deployed on a different machine. What I'm going to do is actually, I'm going to open up another terminal, and we're going to look up the IP address. And if I scroll up, and that's the IP address, 162. So let's go ahead and pull it up here. All right, so we have the site pulled up. Now the vulnerability exists on this page. So let's go ahead. I already have burp open. What we're going to do is copy this. As a matter of fact, Let's minimize this. We also take a look at the source code, what the vulnerability is. But let me demo this first. All right, we're already getting the traffic. Let me go ahead and intercept this. Refresh this. All right. I'm gonna send this repeater. Let's forward this. And there is this API, fetch data. And just drop that. And I can forward this. Now let's take a look at this. If you noticed, this is a post request. It is making a post request using a URL. And anytime you see something like that, there is a possibility it could be exploited to carry out server-side request forgery. Now, the first thing is, let me go ahead and try to see if I could replace this maybe with an outside resource. I'll do my blog site to see if it is actually redirecting to anything else. All right, so I'm getting 200 OK. It's not being blocked. So this could easily be used as well to carry out malware attacks, because I can actually forward to some external page, attacker controlled external page. We can also see it is actually the case, and let me copy this. I believe burp is interrupting it, so let's forward. Yeah, as you can see here, I brought up the whole page. So definitely, this is something we can exploit. Let's go ahead and close. So let's go back and take a look at what the attack would look like. So I have mentioned we have an admin dashboard. Now this admin dashboard is only accessible from the local host. If I were to pull up a browser in here, and as you can see, if I refresh it, it works. So it is logged in and it works. It's accessible from the local host. Now, if I try to access it from here, let me try to open up, actually, let me demo this on another browser. As you can see, it's 403. It's not going to allow me to access it because it's actually internal resource. Let's go back to the home page. Now, are we going to be able to actually exploit this vulnerability and try to see if we can access that resource? So let's go ahead and try to do that. Now, it only works on localhost. So what we're going to do is going to be localhost, but it's going to be localhost to the server because this is a server-side request forgery. We're going to trick this server, which is vulnerable server, to make a request on our behalf. If I were to type this, the localhost on the browser, obviously is not going to get me access to the local host on the remote server. But if I actually exploit this vulnerability, it would be able to, assuming that this vulnerability exists, which we confirmed already, it's redirecting to external site, so it should be able to exploit and look up on an internal site as well. So localhost. As you can see, it returned admin dashboard. And let's go ahead and take a look as well on the browser. I'm going to open it here. Burp is still blocking, so let's turn off the interceptor right now. As you can see, it pulled up. If you look here, admin update in 2025, this is actually basically the dashboard is showing all the source code that is actually the functionality where the dashboard would have. And also if we look in here, updated by admin. And if I go back on the remote machine and I pull up, it's the same thing. As you can see here, this is the admin dashboard. Now, just to show you that's the case, what we're going to do is actually, we're going to put in some additional information, right? Just to confirm. I'm going to go ahead and put in saying this is a dashboard. So downtime planned. I'm on a local host right now. So to update it, it requires me I took it, and if we scroll down, I'll be able to see this. We have a downtime plan, 1 a.m. CST. Now, the way you would know, this is only available on the internal page, and I've demonstrated it earlier on. You get 403. So if I were to refresh this, if it shows that the updated information, what that means is this is definitely an internal page that we exploited using server-side request forgery. So let's go back and let's take a look. And as you can see it, we have a downtime plan 3/19/2025 1 a.m. CST. So with that, I think this kind of demonstrates the attack is actually possible and this is vulnerable. So let's go ahead and look at the source code. Why is this vulnerable? Now, if you look at this fetch API, what it is doing is actually accepting the URL passed from the front end, and there is no input validation or anything. It's just making a GET request. So anytime you don't validate the input and you're just passing it on, that's another issue. And also there are ways to actually validate to make sure this is not something that could be exploited for the server-side request forgery. Now, on my blog site, I actually talked in detail on how to secure this code. Basically, what we would do is actually we would declare a string list that provides, let me go ahead and pull it up, a list that provides trusted hosts, and if it's not part of the trusted host, part of the list, and then it would just reject it. Pull this up. I believe I have it here. So the vulnerable source code, this is what it looks like. I've shown it here already. And as you can see, it passes it directly to the HTTP URL connection. And that's the reason why. Now, why is this code vulnerable? First thing, obviously, it accepts user input without any processing validation. And basically, attackers can, what we saw earlier on, admin dashboard and all that stuff. I was able to access the internal page. Now, secure implementation. Let's talk about that. What we can do in a situation like this is actually we can create what's called an allowed list. It's going to be an array list, and we can define it here. Allowed list. This is a variable name, allowed host, and we can supply a list with a limited trusted host names. In our case, I use as an example, maybe PinewoodStore.com, and then maybe there's another API that needs to access some kind of functionality, then api.pinewoodstore.com. Now, if we define something like that, and I'll try and catch block if we have a if clause. Now, if that host that is passed from, as you can see here, it accepts a URL, that host, and this basically retrieves the host. Let's say if a site is https twitter.com, basically this would retrieve twitter.com, just the host name. Then we would verify it against, is this part of the host list that we defined? If that's not the case, it's basically saying blocked, and which is basically the 403 page that you saw. If not, it would go ahead and make the GET request. Now, like I talked about this on the blog, but how this is fixed was basically what I demonstrated here. You can use an allow list, and also the other options, right? You can block requests to internal networks. That way, attackers cannot reach localhost 169.254, 169.254, or internal services. And also, you can reject malformed URLs, prevents exploitation through tricky URL formats. Additional SSRF protections, block private IP, you can block private IP address ranges, and DNS resolution verification, that's another thing. And also limiting redirects. So these are some of the things that you can implement to, one, obviously, you can secure your code at the source code level and implement that. And the other thing is on your web application firewall, you can implement that. That way you would have a second or third layer of protection. So with that being said, that's all we have for today. Thank you for listening.